So like antiderivatives are important. We haven't really used many antiderivatives the last 2 units because we had our calculators a lot of the time. But if you don't have a calculator and you were, say, asked to accumulate x squared from 0 to 2, what's the answer? Go ahead and get the answer, please. Get this answer. You got it? 1/3 x cubed is the antiderivative, but you have to find the change in the antiderivative. You get 8/3. Okay? Like, it's the only way you can get that accumulation if you don't have a calculator. Antiderivatives are so important that even MIT has an antiderivative contest every year, an integration contest of a bunch of people who just know a bunch of, yeah, they win like a $10 gift card. Yep. Oh, look at this one. X to the 6th plus x to the 4th minus x squared minus 1 over x to the 4th times e to the x plus 1 over x. So I bet you. No, they have 2 minutes. So here's my guess is you divide and you use a technique that we're about to learn today. No, because I'm not going to figure it out. But let's see what they're doing. Yeah, look, right here. Yeah, I'm a math teacher, but I'm not like a college professor here, you know? These guys are all like much smarter than me, okay? They're much smarter than me. Oh. Morrison, you're here, right? Yeah, Morrison's here. Okay, so anyways, we are going to venture into harder antiderivatives, but they are not unfamiliar to us what we're about to do. But we are going to learn a technique that some of you are going to really like jump onto and be like, this is great. I love just doing the same thing over and over and over again. Some of you are like, I would actually prefer to do it this other way, but the technique is actually required for you to know. So you have to know it. So you got to learn it. So here we go. Now, let's see. I'm going to take a little straw poll. Could you take the derivative of cos 3x plus 2 for me? Go ahead and do that. And let me just see your derivative, the derivative. Okay. Covington, you're going to love today's lesson. I can already tell. Hawkins, you're going to like it. We're taking the derivative, Osler. Yeah, Mickelson, you're not going to like it. I'm not going to like it. No, you're not going to like today. Priya, you're not going to like it today. You took the antiderivative. We want the derivative. Bone stop, you're going to like today's lesson. You have to make sure you take the derivative. You got to make sure you take the derivative. I'll show you why in a second. You can't. Don't forget about Vegas. Don't forget about Vegas. What starts in the parentheses? All right. Many of you do not use the technique that we learned for chain rule derivatives. We use this kind of process of identifying the O and the I. We would write down the O. We'd write down the I. We remember the rule about Vegas. What's the rule about Vegas when I say Vegas? Tell your neighbors. What starts in the parentheses stays in the parentheses. We then multiply these together. We get -3 sine Vegas. Cool. And we could do the other ones. We'd be fine. A lot of you no longer use O and I because you understand conceptually, okay, the derivative inside stays the same, and I need the derivative of the inside. So you don't do the O and the I. And that's fine. We, in Unit 6, undid the chain rule when we took an antiderivative of, say, cosine 3x plus 2. Let's see if you remember how to take the antiderivative of cosine 3x plus 2. Good start. I'm recording.
Oh, okay, cool.
So don't make a fool of yourself, or I'll call you by name and it'll be on the internet for the rest of the time. I don't think YouTube's deleting any of their archives, are they? Yeah, so yeah. Okay, so you got it. We're down here though. All right, good. Ooh. Not the right approach. Not the right approach. Guys, don't forget about Vegas. What starts in the parentheses has to stay in the parentheses, not change. Don't forget about Vegas. Vegas works in both directions. Yeah. Nope. Yep. Thanks. Homework. Don't forget about Vegas. Well, let's see if it's right. This is how I taught it to you. Now, the way I taught it to you was very conceptual in its approach. We're like, hey, if we understand the chain rule, we should be able to conceptually understand an undoing of the chain rule. With the first thing being, Vegas will always be Vegas no matter which direction we go. So my answer must have 3x plus 2 inside parentheses. Because whenever we take a derivative, it stays. You know, Vegas is Vegas. So what I did is I taught you to take the antiderivative of the outside. Vegas is Vegas. But we, knowing about the derivative, know that there will be a derivative of the inside. There will be a 3 that shows up. We conceptually undo the derivative of the inside with a 1/3. Okay? Of course, you forgot a plus C. We all forget it, but we need to remember it. Okay. Let's say we're 0 for 1. Okay? Listen, be like the Oakland basketball player. What was his name? Galkey. Yo, even if you're 0 for 1, be like Galkey. Keep shooting. Okay? Try this one. Try to get the antiderivative of this one. Keep shooting. Shoot the ball. You got a hand in your face. Shoot it. You can't score if you don't shoot, says Galkey. Houston, just for fun. Yeah, just because, like, I want somebody new. I want somebody new to go all the way. Uh-oh. Hey, if you're not sure about this one, try this one. Hey, we got to keep shooting. Who's gonna be 1 for 2? Shoot rock.
measure. This is our last game of the season, and we need to win to make playoffs.
Shoot the rock. You don't even have the notes. God. There's 2 copies, Chewy. 2 copies.
Did I do it right? I don't know if I did it right.
Can you go to the right page of the notes?
I still have the
Yes,
packet.
that's correct.
So is it right?
What do you mean you don't have the packet? That's good.
1/2 ln parentheses qx plus 3. He's just saying what I heard. Oh. Yeah.
All right. What we should do, what we did in Unit 6, and it's been a while, is rewrite this as a negative first power. What we should do for this one, but it's been a while, is rewrite this as a negative second power. For one of these two, the power rule works. For one of these two, the power rule doesn't work, so we need to remember the antiderivative that's correct. This one, the antiderivative, does not work with the power rule. So you got to remember log absolute is the antiderivative of a negative first power. Vegas is Vegas. What starts in the parentheses stays in the parentheses. Don't forget about it. And then you conceptually need to undo the derivative by having a 1/2. All right, maybe we are 0 for 2. Keep shooting. Try to figure out this one. Shoot the rock. We needed a shoot the rock. That's actually pretty funny. No, that's funny. We needed a 3-point specialist on our team this year, right? They're in, like, just somebody who could just shoot the rock, you know? Do you know that guy on Oakland? He had something like 400 field goal attempts this season. Like 380 of them were for 3. Yeah, he just shot 3. Sick. Shoot the rock. Oh, add. Okay, you're good. Good. All right. The antiderivative of the outside is a negative first and a negative. I'm going to make that 2 negative. I got Vegas. It stays. But I got to undo the derivative of Vegas. We did this very conceptually. We just kind of understood to undo the derivative. Okay, maybe we're 0 for 3. Keep shooting. Come on, let's go 1 for 4. Let's go 2 for 4. Shoot the rock. Why is there a negative 3? What? What? This? What? Here. Here. What's the power rule for antiderivative? What is the antiderivative of x squared? Yes. The antiderivative of x squared is x cubed times a third. You add 1. What is negative 2 plus 1? Oh, there you go. What? This equation? I don't use the power rule until it's a negative second power. You can't use the power rule in the denominator. It doesn't. Just like I did on the previous one. Yep. What's the last name? What's the last name? King. I don't have a king. King. No. We got Frank. All right. We got the antiderivative of the outside is e to the power. So we take the antiderivative and we got it. Vegas stays Vegas. The Vegas is the power. And we undo the derivative of it. You know? Whatever we ended up as, great. Now, what we did was a very conceptual approach. We knew we had to undo we knew we had to undo the derivative of Vegas, okay? We are going to venture into harder ones where the easy understanding works, but it's going to be more complicated. So I'm going to bring back some letters. You guys first started with O and I. You first started with O and I, and you used those letters to help you take the derivative of change. Then many of you forgot about O and I. I'm cooking. Let me cook. You used O and I to help you take the derivative. Many of you forgot about O and I. You no longer use O and I. That's fine. With antiderivatives, you kind of didn't need a letter to help you go backwards. You got the right answer. I'm cooking. All right, but we're going to bring back a letter. We're going to bring back letters because we're going to have to take antiderivatives of these. Now, I will tell you that the more conceptual approach that we were just using does work, but I tried to teach it that way last year. In the long run, it didn't work. So I'm going to, can you pay attention and throw me that pencil back? Yes, it's hers. Thank you. Okay, since it didn't work out last year, I'm going back to, we're going to use some letters. We're going to use a technique like we used O and I when we first did the chain rule. I will show you the conceptual approach for taking this antiderivative. Watch it. Some of you will be like, that makes a lot of sense. Some of you will be like, I don't know if I can do that. I will tell you that the conceptual approach does not work for all the questions we're going to do, which is why you need to learn this like O and I type approach. We could see the composition of a cube. We could take the antiderivative of the outside. We know what starts in the parentheses stays in the parentheses no matter what thing we do. This is true for antiderivatives and derivatives. Vegas is Vegas. We can undo the derivative of the inside, the 1 over 3x squared. That 1 over 3x squared actually will cancel with this x squared up in front. We didn't take the antiderivative of it. It was just on the outside. I didn't really pay attention to it. The reason why I don't teach this anymore is because people did not know how to handle this. And I tried to tell them just like, don't pay attention to it. But they kept paying attention to it. So like, I'm not doing the conceptual approach anymore. We're going to go back to an O and I type approach. The answer to this is 1/12 x cubed plus 3 to the 4th plus 6. I got this conceptually by taking the antiderivative of the outside, undoing the derivative of the inside. I had a 1 over 3x squared. The x squareds cancel, leaving no x squareds. I got 1/12 x cubed plus 3 to 4 plus 3. If you got that, if you understand that, great. But if you did not understand that, and if you liked the O's and the I's, remembering the O's and the I's, remembering like this technique that helped us to go backwards or helped us to find the derivative. Techniques sometimes help. We are going to learn a new technique to go backwards. This technique uses a letter That's not O and I. This technique is called U substitution. Here's why I think it's called U substitution. What did we do on the antiderivatives that you guys were shooting your threes on? What is a cool, important thing when we're undoing the chain rule? You got to undo. You got to undo the derivative. I think of U substitution as like, hey, we're going to undo O and I. Okay? We have this first example, which I already told you the answer to. I'm going to show you a different way to get the same answer that is very much a U, O and I type technique. It's an O and I type technique. It's called U substitution. U is going to undo. And let me just show you what happens. Like when we kind of take antiderivatives of these chains, what we worried about first was the outside. And we took the antiderivative first, and we worried about undoing the derivative second. Would you agree with me? You said cosine's antiderivative is sine, then undo the derivative. This technique goes in opposite order. U substitution, the O and I kind of technique for undoing the chain rule, undoes the derivative first. It undoes Vegas's derivative first. And then we worry about the antiderivative last. You remember how we did O and I, and we had some work on the side, a lot of times below. Well, here's what we're going to do. We're going to do some work on the side with U substitution. It's very much just like O and I, which a lot of you had to do, and a lot of you still do. And here we go. On the side, we are going to take U and set it equal to Vegas, whose derivative we need to undo. We are going to undo Vegas and its derivative. First, we are going to take the derivative, 3x squared. We need to undo this derivative of 3x squared. Now, here is how kind of this works so we don't have to think about things so conceptually. You're going to take the derivative of U and you're going to say it's the derivative of U, du. It's a very simple kind of process. It's called a partial derivative. We're just going to say U's derivative is du. We're going to say x cubed plus 3's derivative is 3x squared dx. Again, this is just an O and I procedure. You're going to have to practice it a couple times and then you're going to get it. We are going to solve for dx. And when we solve for dx, it's like we are undoing the derivative of x. I need a 1 over 3x. That's going to undo the derivative of x cubed plus 3. Just go with it. Now, here's where the technique works. Here's when we are going to undo the derivative of Vegas first. We'll worry about the antiderivative later. We are going to take x cubed plus 3, and we are going to replace it with u. We're going to say that's Vegas. Vegas is u. We are going to take the derivative of Vegas and replace it with what it's equal to. This is the substitution step. Everything else stays the same. X squared is still x squared. We still have parentheses cubed, but inside I'm going to say, well, that's Vegas. It's u. I'm undoing it. I'm replacing the derivative of x with the derivative of Vegas. The x squared will cancel. We have just undone the derivative of Vegas. We did it first. We realize that what we have left is just 1/3, I'm just rewriting this multiplication step, u cubed. The derivative of Vegas is already undone. Now, the last step is to take the antiderivative. We have the 1/3 that stays. We add 1. We multiply by the reciprocal. We have a plus c. Can you see how we get that same answer? 1/12 Vegas to the 4th plus c. 1/12 Vegas to the 4th plus c. Yeah. I took the antiderivative of u cubed. All right, let's replace this one with another example that I'd like you to do because I don't think it helps you to see the notational derivative. Okay, ready? X squared plus 3 squared. Instead of the conceptual approach, because things are more complicated, we're going to go to an O/I type approach. What are you doing with your phone?
I wasn't using it.
Okay.
Using
Okay. My daughter's favorite animal is a pig. No, I'm not going to do it. All right, go. Take that antiderivative. Now, here's what we do. We say, you know what? Let's undo Vegas's derivative first. We're going to use u equal to Vegas. We will take the derivative of Vegas. We need to undo the derivative of Vegas, so we're going to solve for dx so that we have this kind of like reciprocal derivative of Vegas. We'll end up with 1/6 x squared plus 3 cubed plus c. This is our answer. Let's see if you can get it.
So I don't have to use the
You'll have to use the u, I promise. I'm going to show you 3 different examples where it's like, if you don't use u, you're really hurting yourself a lot. Yeah. Yeah. Okay, great. Good.
My question is like, where does it? Like when I
So when you take that's a great question. When you take the antiderivative of u with respect to u, you just get u. It's like the du goes away. Whenever we like say accumulate x squared with respect to x, and you take the antiderivative, where does dx go? Well, you've taken the antiderivative. It goes away when you take the antiderivative. Yeah, when you take the antiderivative. Yeah. All right. Ryder's got it. Follow him. Here we go. We got to do a lot of examples because this technique, similar to O and I, demands practice. We use the letter u. U equals x squared plus 3. We need to undo Vegas's derivative. So we need Vegas's derivative. We write it as du equals 2x dx. That's Vegas's derivative. That needs to be undone. So I will solve for dx to undo Vegas's derivative. I will replace dx with what it's equal to. I will undo Vegas's derivative, dx. Everything else stays the same, except we're going to replace Vegas with u just so it's easier to kind of see. We notice that the x's will cancel. We now have 1/2 u squared du. What we just did, this process, undoes the derivative first, worries about the antiderivative last. The more conceptual approach that some of us use, I'm moving people. The more conceptual approach works on the antiderivative first and then worries about undoing the derivative last. This is an opposite order of things. we take the antiderivative, which is a step a lot of people forget. All this work is just to undo Vegas's derivative. It's undone. We have to take the antiderivative. That's where I need a 1/3 times the 1/2 u cubed. That turns into the 1/6 Vegas cubed. Okay? Let's do another one. Let's do 2 more. Don't do this one first. No, keep it like this. This is 3x squared, 9 minus x cubed, cubed. That's a problem, and then you got the problem on the left that we also did. Yes. Yes, we care about Vegas and its derivative right away. We're going to undo Vegas's derivative first. We'll take the antiderivative second. I will write down the answers. No, we're going to do that next. Okay. Those are the answers to the 2.
I keep forgetting my.
Not that bad. Just like O and I, this is not that bad. Once you've done it a couple times, it's like, all right, I got it. I need you to come back and make sure you're ready for the second way, okay? Because there are specific questions where the second way is required.
Okay.
Can you just go?
Yeah.
Yeah? Great. So it's just a technique, just like O and I is a technique. Techniques don't involve that much thought, honestly. You just have to make sure you know how to do the technique. Yes, yes, that's exactly what happened. So, as some of us have noticed, maybe the conceptual approach is not going to lead to the right answer because you make a mistake conceptually, versus the U substitution approach, similar to O and I, always going to work. U substitution will work if you do it correctly. That's why we keep shooting. It's exactly why we keep shooting. I'll do the harder one. I'm going to worry about Vegas and its derivative first. There's Vegas's derivative, which I will undo by dividing it. I have 3x. I have Vegas to the 1/2. I'm going to just use U as Vegas. I will undo Vegas's derivative. I will replace the derivative dx with negative 1 over 2x du. The x's cancel. Great. I now have 3/2 u to the 1/2 du. When I take the antiderivative, du goes away. The antiderivative of u to the 1/2 is u to the 3/2 times 2/3. That 2/3 and the 3/2 will cancel. I still have a negative, though. Don't forget about that negative. Don't forget about that negative, which is why we get this as our answer.
On the right, we just wrote it. Yeah.
Okay, I won't do the one on the right, but we can all do this one.
Yeah. Is it? Wait, hold on. Wait. Keep working.
We want to undo Vegas's derivative. U substitution undoes Vegas's derivative first. So we have U, which is Vegas. We take its derivative. We undo its derivative by like dividing. Sometimes we'd have to multiply. The answer should be 1/4. Negative 1/4 cos x to the 4th plus 6. What?
-1.
No. Just do it.
Okay, this x to the third, this x to the third, okay, we have 1/4. Okay, now the derivative of sine, negative cosine.
Yeah, we always undo Vegas's derivative.
The negative cosine, you put back in what you had originally, and you add c. I don't understand.
Okay, wait. Actually,
We gotta move, but yes, here we go. Here is Vegas. Here is Vegas's derivative undone. We say I got the sine of Vegas. I'm replacing it with U. I am undoing Vegas's derivative. The x cubed will go away. I do have a 1/4. Now that 1/4 is not inside sine. That 1/4 very much is in front of sine. Is better to look at. You take the antiderivative of 1/4 sine U. The antiderivative of sine is negative cosine. We don't have to worry about Vegas anymore. It's just like U. It's just one variable. So we get negative 1/4 cosine U plus C. And that's how we get our final answer. Because that's Vegas. You didn't undo Vegas's derivative. You have Vegas's derivative. Burma. This is Vegas's derivative. It needs to be undone. It's like we need to divide by that 1/4 x cubed, just like we've divided by the 1/3 and stuff like that, or multiplied by the 1/3. All right, now here's one benefit. Go straight to this. I want to give you an easier problem. So that we get an answer. So I'm going to change some stuff up so we get a decent answer. So I'm pretty much going to invent a new question. Make this never works out.
Are we doing that question, or are you just thinking?
I'm thinking. All right, just change this to a 1, and it'll make it easier at least a little bit. Okay, now. We are accumulating accumulating now. It's not just an antiderivative. With the numbers, it means accumulate. We are going to get an answer, a numerical answer. Now, our numerical answer might be like an ugly subtraction of some ugly things, but it's still going to be a numerical answer, like a calculator-ready answer. Now, I'm about to show you something that you might be like, that doesn't make sense. Why would I do that when I can just do this? But I'm going to tell you because there are going to be specific problems that require you to do that are coming up next. Okay, let's go ahead and know that we have to take the antiderivative. Let's focus on Vegas. Okay, let's undo its derivative. There is the derivative. Make sure we undo it by dividing by 2x, so you have dx is equal to 1 over 2x dx. Okay. Pause. Don't put any numbers here. I'm going to show you something. We got x, it stays x. We got the square root of Vegas. I'm going to replace it with u. And I got 1 over 2x du, the derivative of Vegas, which needs to be undone, which this process does. X will go away. And I'm going to just rewrite this as 1/2 u to the 1/2 du. Pause. Don't take the antiderivative yet. What? I don't think it does, but we're good. Now, the key to the U substitution process is that it does a lot of your work earlier. Okay? Like, we undo the derivative first. We take care of that first. We do some work earlier. What is the last thing we need to do is take the antiderivative and then plug in 0 and 1 and subtract it. Well, I'm actually going to do that work earlier too. And we are going to do a process that's called changing your boundaries. It's also called like change of basis. Now, it's a fancy word for, hey, let's just do some more work earlier on. Let's go ahead and knowing that we're going to have to plug in 0 and 1 into Vegas, which will end up inside my antiderivative, let's just plug it in now. Let's plug in 0 and 1 into Vegas. Or let's turn these x's into u's. 0 and 1 are x's. Let's change them to u's. So I'm going to put 2 and 3. How did I do that? Tell your neighbor. You plug in 0 and 1 into Vegas, you get 2 and 3. You plug in 0 and 1 into x squared plus 2, you get 2 and 3. Now watch this. Watch this. I'm going to keep 2 and 3 here. I'm going to take the antiderivative. The antiderivative of 1/2 u to the 1/2 is u to the 3/2 times 2/3. I still have the 1/2 plus c. Well, since I've already plugged in 0 and 1 and I changed it to 2 and 3, I could plug 2 and 3 into this. And I will get my answer 1/3 3 to the 3/2 minus 1/3 2 to the 3/2. I can't write. Now you're probably thinking, well, Mr. Messner, Vegas is Vegas. Why don't I just replace it with x squared plus 2 to the 3/2. And why don't I just plug in 0 and 1? Well, you will plug in 0 and 1 later. You will still get 3 and 2. You will get the exact same answer that I get, only I did the work earlier, you did the work later. So why can't I just do some of the work earlier and some of the work later, Mr. Messer? Well, there's going to be specific problems where you're required to change your bases, which I'll show you after we do one more problem. This guy. Get that next one. That next one is very much, we're going to go back to it. The x plus 1 over root x minus 1. That very much is a MIT integration technique challenge problem. We'll get to it. Let's go to this one. All right, we got x cubed plus 2 in the power of e. We have x squared in front. We are finding the accumulation from 0 to 1. Let's go ahead and get the numerical answer. It's going to be the difference of e's to certain powers, and that's okay. Now, obviously, you know where Vegas is, and you know what its derivative is. No. Tucker, you show me the answer to this problem with all of the work provided and not copied down from anybody, you can go to the bathroom. Don't look at it and be like, oh. What? What? You know, some people like to use the restroom when they don't want to do any work, mentally or like on paper. Okay, great. Well, show me that you actually are picking up anything that I'm putting down. Okay, so do this problem and then go to the bathroom. No. So you're not thinking about Vegas. Vegas is just the power. Step 1, guys, what's Vegas? Vegas is not e to the x cubed plus 2. Vegas is x cubed plus 2. It's what's in the parentheses. The parentheses aren't there. Like, that's the inside of your composition. Then you can't use this technique. Great question. And it wouldn't be an antiderivative that undoes the chain rule, because it's not something that like comes from the chain rule. High.
Wait, this is right?
Yeah.
Well, besides the e part.
You did the conceptual way, and that's fine. Of course, that's all you care about. And then it comes to so plug it in, yes I know. And then it comes to the quiz, Barbara, and everything goes well. You plug it into you, not into you. You plugged it into you.
All right. Is it this?
Yes, the answer is 1/3 e cubed minus 1/3 e squared.
What do you do once you get here? Then you
Take the antiderivative.
which is going to
1/3 e to the u.
this part?
Yep.
1/30. It's going to be 1/30 to the u. You're burning that fast. I'm just trying to figure it out. I'm switching over my paper. If the derivative of u is e to the u, then the antiderivative is going to be u.
And then
I don't know.
this one's tricky for various reasons. All right, let's do one more after this, And then I'm going to show you why we have to use this technique. Ready? If you didn't get it right, it's okay. Keep shooting. It'll start dropping. The derivative of Vegas is 3x squared. The undone derivative of Vegas is 1 over 3x squared. I'm going to do all of my work early, which includes plugging in 0 and 1 into Vegas to get 2 and 3. I have the x squared. I have e to the Vegas, which I'm going to replace with u. I'm undoing Vegas's derivative, which 1 over 3x squared du. And I notice that the x squareds cancel. Now, we kind of practiced this earlier. What is the antiderivative? And again, this technique does the work of undoing the derivative before you take the antiderivative. What a lot of people forget is taking the antiderivative with this technique. Our job is to now take the antiderivative. Now think of it as 1/3 e to the x. The antiderivative of 1/3 e to the x is 1/3 e to the x. I'll use this line to denote this is the antiderivative, find the change. I will plug in 3 and 2 and get the answer. Many of you will go back to x's and you'll have 1/3 e to the x cubed plus 2, and you will plug in 0 and 1, and you will get the exact same answer. I just did the work earlier. That's the answer, 1/3 e cubed minus 1/3 e squared. Why is it minus and not plus, Bodenstaub?
You're taking the accumulation.
If f prime is positive, f is going up. What's the accumulation of f prime? It's some number. Let's say I don't know this number. Hold on. Let's say, Bodenstaub, I don't know this number. Well, let's say I know f of 0 was 5 plus c. Let's say I know f of 4 is 9 plus c. So I don't know the accumulation of my derivative. I don't know this. But I know some antiderivative values. I know f values, they have some c's. I know that the derivative is positive, which means my function's increasing. I know this is going to be a positive number. What is this number, Bodenstaub? And how did you get that? No. 5 plus 4 is 9. But how can you use these two numbers to get 4? This minus this. 9 plus c minus 5 plus c is 4. That's why we subtract them. Got it? Don't say sure, like you don't understand. This is as easy of a fundamental understanding of calculus as there is in the world. I'm certain of it. What, Tucker? No. You do the next problem and then you can go to the restroom. Stop it. Yeah, fine. Don't do the next problem, then don't go to the bathroom. I don't care. You can just sit. Yeah, I'm fine. That's fine. I'm going to make it easier. Did I just swear? I didn't swear. Did I swear? Oh, yeah, you're right. All right, get the answer. Tucker, get the answer or you go bathroom. You pay attention. Hey, shoot. Shoot the ball. Bone stop. Shoot the ball, okay? No, it's just for this example. Well, this one's going to be changed to 1 and 2. Because you're going to have to plug in 0 and 1 into Vegas eventually. If I plug 0 and 1 into Vegas, I get 1 and 2. Plug in 0, you get 1. Plug in 1, you get 2. Yep. That's doing your workaround.
1 plus 1. Oh, I forgot about the 0. I just ignored it. Oh, anyway. And then you
Yeah, keep it up. Keep it up. What do you gotta do? That's 3 spectacles. It's 7-6. You guys know all the difference. You got the 3 spectacles, you got the 3 goggles, and then you got the superhero 3. This is what I do. I go like this. All right. What, Matt?
Oh, yeah, I got it.
Okay. That's the answer.
Yeah, and then minus 1 change.
I changed the boundaries. You didn't have to change the boundaries, but you will too. If you went back to 1, if you go to 1/6 x squared plus 1 squared, sorry, cubed, and you plug in 1 and 2, you're still going to get that answer. Okay. Verma, here's where things are going to go awry for you. There are going to be specific questions that actually only care about the work of undoing the derivative and of changing the boundaries and don't care about the antiderivative. So there are specific questions. Where they're like, hey guys, this integral right here, I would like you to rewrite it as an integral with u's, and I want you to figure out what is this number, what is this number, and what is this number. Okay, go. Actually, I'll show you, and then you'll do the next one. Watch. Watch, watch, watch. It's a notational one. It freaks out a lot of students because of the notation. But you see Vegas inside of F. Focus. You're about to do one, just like this. Okay. Here's Vegas. Here's Vegas's derivative. Here's Vegas's derivative undone. Here are my x's. I'm going to go ahead and do some of my work up front, and I'm going to change them by plugging them into Vegas, into u's. $18 and $8, boom. I'm just like doing some of the work up front. I now have f of Vegas, which I replaced with u, and I have undone Vegas's derivative. I have a 1/2 du, and I'm told that this equals 6. Many students were like, cool, I got this. The answer is 8 and 18 here. And they think, I guess like the 6 stays as a 6, and they circle this answer on the multiple choice question that they have on their test. They're wrong. 6 is not correct. Just like last class on our integrals properties quiz, if you have something, a constant inside an integral, you can get rid of it. It comes out, but I'm going to multiply by 2. So like this 1/2 comes out in front. I'm sorry, I want to make sure this is clear. This 1/2 comes out in front. I will get rid of the 1/2 by multiplying by 2. This is very similar to the idea that we had on our quiz, like we had 3g of 8x equals 12. You pulled out the 3 and you divided both sides by 3. So that helped us to understand you could pull out this 1/2, multiply by 2. This is a 12. Your turn, but just change this to a 3 instead of a 1/2. Yeah, just change this to a 3 instead of a 1/2. And then I will show you another problem, Verma, which is beyond your capabilities, but it shows you the necessity of using this technique where conceptually it doesn't work out. Go ahead, please. I would like you to rewrite this as an integral of f of u du. I would like you to find what this number, and what this number is. I'm telling you that this integral equals 5. I'm asking what is this integral equal? No, you don't get that. You're multiplying both sides by 3? Oh my gosh. Oh my goodness. They just started. It just started. You're that work. Yeah, they're winning or they're losing. They're winning. Give me that. No. This should be 7. This should be 13. This should be 15. That's it. Yep. What? The other problems that we did? Yeah, sure. Yeah. 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 But like, because then you don't understanding it and you're just memorizing one stuff, and we don't like to learn by memorizing. We like to actually just like understand. We don't be like, what? Why can't I just add them? You know? We don't want to just like be like, can we just add them? You know? We don't want to do that. We want to understand.
Like, who was like 7 Why? We're just thinking outside the box.
Go, geniuses. No. You're close.
Tucker's all over the
Give me your phone. Okay. Did you learn anything out of this? Did you learn anything today? Why is it okay for you to not pay attention, but everybody else is okay to pay attention? So the x's cancel, Anderson. It's not 12x, it's just 12. It's 3 to 12 of f of u equals 12. If they don't cancel, then we're not undoing a chain. And that is a great segue to these questions that were right before what we just did, right here. Go to this one right here, right here. Go to this one. Go to this one right here. It's on the previous page.
There's no numbers?
No numbers. Yes, please.
You forgot about the
No numbers, so you just have to take the antiderivative. You do not have to subtract anything.
So we're just doing it normally.
We're just taking the antiderivative. We're going to have a plus c as our answer. And many of you will get the answer 1 over 6x, x squared plus 3 cubed plus c, and you are round. I undid the derivative of the stuff. So there have been a couple of people that came out and have asked the very important question, does it always cancel? The derivative of Vegas? Will it always cancel? And the answer is no. And if it doesn't, then you aren't supposed to undo the chain rule. That's not the technique you use. This is where the MIT competition comes from. There's all these techniques. Some of them work, sometimes, some work, other times, yes. So you probably are like, oh yeah, u squared 1 over 2x du, but you can't take the antiderivative of u's and x's. So when stuff doesn't cancel, guess what? This was an incorrect approach. Sometimes you got to use different approaches. You know what the approach is that you always need to remember? Simplify. Do you know how to take this antiderivative? You square x squared plus 3. And then you take the antiderivative of all of those individual terms. This is literally a test question. I'm just telling you right now. You have this on your test. And many of you will mistakenly select the answer that is kind of like the undone chain, but this isn't a chain that can be undone. It's not a chain that can be undone. Because what's the derivative of Vegas? I can't undo 2x. There's no x's to undo. You have a 1 over 2x. Like, if you think this is the answer, 1 over, it ends up being 6x, x squared plus 3 cubed. If you take the derivative of this, you're not going to get that. Why? Because you have to use the product rule or the quotient rule. If you use the product rule on this, stuff's not going to get canceled. It's going to be a very, very messy derivative. Not going to be that simple derivative. Okay. Lastly, zero to 1. Fourth quarter, guys. Finish strong. Listen. We're doing the one on the right. We'll do another one on the left. Just flip around until you find it. Look at the guy on the right. What do you think you do here? No, simplify doesn't work.
I'm not saying simplify, I'm saying you have to change it. So like what it
3x times x squared plus 5 to the negative first. Nailed it. If you did that, great instinct.
That's what I did.
Now, finish the problem. Sharp, I'm not happy with you. Okay. Same idea. Vegas's derivative. Vegas's derivative undone. Many of you will be sloppy with your notation when you do this, but honestly, I don't care. The 3x and the 2x cancel to just be 3 halves. I hate when this jumps around. We have 3 halves u to the negative first. I probably should be changing 0 and 1 to 5 and 6. Do some of the work ahead of the game. The antiderivative is 3 halves log absolute u plus c. You've already plugged in 0 and 1. You've already just replaced Vegas with u. You can get this answer. Just by plugging in 6 and 5.
Do you want us to take out?
Now,
3 halves versus L and 6 versus 5.
you could do a lot of stuff here. You could pull out the 3 halves. You could do ln 6 minus ln 5. You could use log properties to write this as log ln 6 fifths. You could rewrite this as ln 6 fifths to the 3 halves. But we honestly don't care. All right. Hey, good job today. Appreciate it. Except for you.
Except for me.
You. And you. Are you watching something right now? Great. I'm 1,000% confident that's a true statement. You are lying to me is what I'm trying to say. More, I'd like you to join the team next class.